Yay Notes, today is all about the chemical formula. Now the first thing we need to know what a chemical formula is. A chemical formula is a list of all the different elements that are in a compound. It's not only a list of the elements that are there, but it's also the number of elements that are in that compound. For example, probably one of the more famous chemical formulas is H2O. Now, just looking at this, I can see that we have two different elements. We know we have two different elements because we have two different capital letters. Every time you get to a capital letter, it is a new element. So we have the hydrogen and we have the oxygen. And then we have a little bitty 2 down there. That little bitty 2, that's going to tell us something else. That's going to tell us how many of a certain element. Now that little 2, it has a special name. It's called a subscript. Subscripts are to the right of an element, and they tell you how many of that element there are. In this case, 2 is to the right of hydrogen, so it says we have 2 hydrogens. There's nothing to the right of the oxygen. Anytime you write an element, we assume that there's one of them there. So we don't have to write a little subscript 1 next to oxygen, but anything more than 1, and you do have to write the subscript. The next thing you really need to know about the subscript is it can never be changed. If I changed that little 2 in water, I would have a completely different molecule. So I cannot ever change the subscripts because that changes what my compound is. So this little 2 right here, very important. It only applies to the hydrogen, not to the oxygen, and it cannot be changed. Now, we have another element here, or I shouldn't say element, another compound here, potassium nitrate. KNO3. You'll notice this is in one of your boxes at the bottom. So if you look at the bottom of your fill-in sheet, it's already listed out for you. What I want you to do, talk to your table, see if you can identify the number of each type of atom in the equation. Your mark it, set, go. So, potassium, how many potassiums do we have in this compound? One potassium. How many nitrogens do we have in this compound? 1. Also 1. How many oxygens? 3. And we have 3 oxygens. That one was pretty easy. Let's try one more. This one confuses some people, and the reason it confuses them, we have a nitrogen, we have a hydrogen, and that, is that a Cl or a Ci? Cl, chlorine. So there's 3 different elements here. Talk to your table. You get about 10 seconds. Identify how many of each type go. All right. So, nitrogens. How many nitrogens do we have here? 1 nitrogen. How many hydrogens do we have? 4 hydrogens. And chlorine, we have just 1 chlorine. Continuing. Uh-oh. We're going to take it up a notch. This seemed a little bit too easy for you, so we're going to make it a little bit tougher, but not much. Now we're going to have magnesium hydroxide. Now, magnesium hydroxide is a bit more unique because it's going to have parentheses. Now, parentheses in science are a lot like parentheses in math. Many of you who are fans of the Kai, yes, you're going to think, oh, I know how to do parentheses and a number on the outside. I have to distribute that to all the different elements that are inside the parentheses. Now, is magnesium inside the parentheses? No. So it does not get the distribution. Is the oxygen inside? Yes. Is the hydrogen inside? Yes. Okay. So the 2 is going to need to be distributed to both the oxygen and the hydrogen. go ahead, you get about 10 seconds, work with your table, see if you can figure out the correct number of each type, go. So when we figure this out, we're going to have to know that this 2 does distribute to the H and it does distribute to the O. First question, how many atoms of magnesium are here? 1 magnesium. How many oxygens are here? 2 oxygens. How many hydrogens are here? 2 hydrogens are there. So I told you, not much more difficult, but it was stepped up a little bit. Now, calcium phosphate. A great fun one. We have parentheses, we have lots of numbers, we got lots to multiply. So, once again, spend about 10 seconds, talk it over at the table, see if you can figure out calcium phosphate. So we're figuring this out. How many calciums do we have? 3. Calcium is not inside parentheses, so it does not get any distribution. Calcium does have 3. Phosphorus is our next element. How many phosphoruses do we have? We have 2 phosphoruses, because 2 times 1 is 2. Now oxygen is 2 times 4. That gives us 8. 8 oxygens are there. Next, taking it up one more notch. This is so simple, we need to just expand a bit more. Now we have a number in front. Not only do we have these subscripts, the little numbers to the right, we have one full-size number in front. We're going to call this a coefficient. Now a coefficient tells you how many molecules we have. So this number affects the entire molecule. And this is going to multiply times every element and coefficient that comes after. So this large 6 in front is going to multiply times everything in the compound. It will be distributed to the carbon, the hydrogen, and the oxygen. So this is the number we're talking about, that large full-size 6 in front. It's going to multiply times each individual atom in the element, or in the compound. So, spend about 10 seconds to determine how many carbons, hydrogens, and oxygens are in aspirin. So in this one, our numbers are going to get a bit larger because we have 6 molecules of aspirin. Each molecule does have 9 carbons. So how many total carbons do I have?
54.
54 carbons. 6 molecules, each having 8 hydrogens. So what's my total hydrogen count? 48 hydrogens, and my oxygen count is 24 oxygens. Whoa, buddy. Now, continuing on. Yay, notes. The coefficient, this is what we use to balance an equation. So coefficients are used to balance equations. The reason we balance an equation is the law of conservation of mass. This law states that atoms cannot be created, they cannot be destroyed in a chemical reaction. If we start with 3 atoms of carbon, we have to finish with 3 atoms of carbon. They can be in new compounds, but we still have to have the same number at the start as we do at the finish. That means that the reactant side, what we start with, has to be equal to the product side, what we finish. So each individual number of atoms on the reactant side has to be equal to the individual number of atoms on the product side. The only thing we can change is the coefficient to make this happen. Remember, we cannot change subscripts. We cannot change the little numbers inside each individual compound, but we can change the large numbers in front. And when we change the large numbers in front, that will balance our equations, it will lead to the law of conservation of mass. So looking at this formula right here, we have hydrogen, we have oxygen, then that arrow means reacts to form, and then we have water. So anytime you are given a formula, first thing you need to do to figure out if it's balanced or not, if it follows or if it obeys the law of conservation of mass, you have to count the number and types of atoms on each side. So the way I do this, I like to list out my elements right under the arrow. So my elements are hydrogen and oxygen. On the reactant side, so this side over here is the reactant side, this side over here is the products. On the reactant side, how many hydrogens do we have? 2. Now, how many oxygens do we have? 2. On the product side, how many reactants do we have? I'm sorry, on the product side, how many hydrogens do we have? We have 2. How many oxygens do we have? 1. Now, is everything equal and perfect? No, we need more oxygens. But which side do we need more oxygens on? Products. I said the only thing we can change is what? The coefficients. So I'm going to have to change the coefficient. Right now, we can understand that if there's nothing written, there's a 1 in front of every one of our molecules, yes? So instead of a 1, I need to change that to a 2. I'm going to put a 2 right there in front of water. When I put that there, that's going to change the number of hydrogens and the number of oxygens that we have. So now we're going to have 4 hydrogens and we're going to have 2 oxygens. Now is everything equal? No. What do I need more of? Hydrogen, which one? Reactant hydrogen. So I'm going to put a 2 in front over here. It's going to change that to 4. And now everything's equal. That's the understood 1 right there in front of oxygen. So you put a 2 in front of hydrogen, a 1 in front of oxygen, and a 2 in front of water. Now it's all balanced. You have the same number of each type of atom on both sides of the reaction. Easy enough? Okay. So we just said that right now, number of hydrogen on the reactants and products match, but the oxygens don't. So it is unbalanced, and I just showed you how to balance it. You balance it so it obeys the law of conservation of mass. Just like that. We added the coefficients in front of hydrogen and in front of water. Now it is balanced and it obeys. So this one right here. I'll do one more example with you, and then you're going to do a few at your table by yourself. Remember, I want you listing out the elements under the arrow. So my first question, anytime, is going to be, is it balanced or not? So to determine if it's balanced or not, we list out our elements. We have sodium and we have oxygen. On the reactant side, we have 1 and we have 2. On the product side, we have 2 and we have 2. Is everything equal? No. So is this balanced or unbalanced? Unbalanced. So what do we have to do to balance it? So I can change the coefficient. I can put a 2 right there. If I left this at 1, left this at 1. Now, is it balanced? Yes. So that's all you need to do. What I want you to do, spend about 5 minutes, finish up the next 3 examples with your table. Check with your table to make sure everyone there agrees. And then we're going to throw up the answers in just a minute. All right, here are the answers. Make sure you got them correct. Let me know if you have any questions.